ketone or aldehyde, we are using 2,4-dinitrophenylhydrazine. I'm going to add about 0.1 gram, is like the tip of a spatula. And if it is more than 0.1, still is okay because it's qualitative analysis. And I'm going to dissolve that in ethanol. Add 1 full dropper of ethanol to dissolve. And after it dissolves, we are going to add 3 milliliters of the reagent. Upon addition of this reagent, a yellow precipitate will form if we have aldehyde or ketone. Two and 3. I'm adding 3 full dropper of the 2,4-dinitro. The precipitate has formed. It's cloudy, definitely cloudy. The precipitate has formed. And this formation of precipitate, it says or indicates that the sample of the unknown is either aldehyde or is ketone. I'm going to save this, and it's also in the procedure. We save this for later, for the derivatazation part. I'm saving this sample. It's going to save me some time. But before moving forward, I want to make sure to distinguish between aldehydes and ketone. Is this compound, what I have, is it aldehyde or ketone? Because both of them would give positive tests with the 2,4-dinitro. To distinguish between the two, I'm going to prepare the toluene reagent and test the sample with the toluene reagent. If it gives silver mirror, it would be toluene. If it's no silver mirror, no reaction, it would be ketone. To make the toluene reagent, I'm using 5% silver nitrate. You have the procedure. Just as add 2 milliliters, which for me is about 40 drops, because I prefer the sample of the silver nitrate to stay in a dropper bottle, because if it touches your skin, it's going to cause black stain, and only time is going to remove that. Basically, it oxidizes something in your skin, and it leaves like black skin, and your skin will peel off before it comes out. And we are going to add sodium hydroxide, 1 drop of the sodium hydroxide to get that precipitate, the brown precipitate that forms here. And now we're going to add enough ammonium hydroxide until it changes to clear solution. And based on the common ion effect here, is going to make, basically is going to make an ammonium complex that it is soluble. So I just add enough until the solution is clear. Just preparing my toluene reagent. It is clear. And to this, I can add the unknown. I would add very small, the procedure says like a match size, these like very small amount or 1 drop of the sample. I would add to the toluene reagent and mix it just once and then leave it alone. If a black precipitate forms, it could mean that there is a reaction. If silver mirror forms, definitely there is a reaction, and your unknown would be aldehyde. Well, none of that happens yet. I can wait for this, or I can come to conclusion that this is not aldehyde, and it could be ketone. So we have already, it's been a while. Okay, it has been 10 minutes already. and there is no black precipitate or there is no silver mirror. So definitely the compound is not aldehyde. So since we know it's not aldehyde and there is a precipitate here, this means that the compound is ketone. Now, we already know it's ketone. What would be our next step to determine what is the name of this ketone? We have the melting point for this unknown. The melting point was around 46 to 47. There are few compounds that is ketone and it has a melting point around like between 40 and 50. And we are not sure, we cannot depend on one physical property. So to make sure to distinguish between the ketones that they have melting point between 40 and 50, we are using the derivative of the ketone and measuring the melting point of the derivatized product. The derivatized product is the yellow precipitate we have here, yellow to orange. In this case, is orange precipitate that we have here. The table that is provided in the lab manual, it shows the melting point for several ketones and melting point for 2,4-dinitro derivative of those ketones. So if we have the melting point for the, we are going to filter this, recrystallize, and then we are going to dry the sample, measure the melting point. Then based on the matching melting point, we can identify our anode. And that was basically major last step. So we're getting ready to do the vacuum filtration for this sample. Okay, our crystallization should be complete. It's been more than 10 minutes that I was sitting. And at this point, we are going to use a vacuum filtration to remove the, to recover the crystals using the filter paper. I'm not measuring the mass of filter paper in this case for change because I'm not concerned about how much crystals I have. I'm only concerned about what is this crystal and what's the melting point. So I'm just using the filter paper without measuring the mass. This crystals first is going to be washed with cold sodium bicarbonate to remove any acid that is left from the reagent. So we're just going to add about 5 milliliters, not much, about 5 milliliters of the sodium bicarbonate to wash. I already used about 2 drops, 2 dropper full to wash it. The better practice would be to add the solvent while the vacuum is off and then turn on the vacuum. Then we wash with cold water. Close the vacuum. I add the washing solution, which in this case is water, and then I turn on the vacuum. Because it's very important for me to make sure the product is pure, I'm using the recrystallization. And because it's going through recrystallization, I don't have to wait for 5 extra minutes for the sample to dry completely. So I would just remove it and transfer to a flask, to an Erlenmeyer flask for recrystallization. So I have my sample. I'm going to carefully transfer that to a small flask. You can use a spatula to scrape it off and transfer. You want to transfer all of your sample just to make sure that after recrystallization, you have enough for melting point and saying that if you have enough for melting point, you're fine. So we are using ethanol and about